Hey software, welcome to your third lesson in Unit 4. This is going to build on the idea of using conditionals to make things happen to animated shapes or elements in your code. And so we are going to build off of similar things from the code along in that first lesson. If you don't have an editor with any of those things, I would pause this video and go make it. I'm going to walk you through the things that I have in my code, so if you are not sure what you'll need, you can follow along, pausing to type it into your own editor. So I have, on lines 1 and 2, two important variables. One is circx, which is controlling the x position of the only circle in my program. I'm just saying circle 1 because in a world where I added more shapes, I want to be able to differentiate. I also have a variable called circSpeed, SPD, and that is controlling the speed of my circle. This variable is going to become super important, so if you have been ignoring the fact that I've been using speed variables until this point, you now need to start using them. I also have a circle x value and a circle speed value. And then down here I have my ellipse, using circle x to control the x position, incrementing circle x with the speed, and then like before that you saw in the last video, I'm displaying the coordinates of my circle. Lines 17 through 19 on my screen, you do not need to copy in unless you really want to see values printed out. This is just so that we, on this video, can be very aware of what the actual coordinates are in something larger than the console. So when I hit play, this should look very familiar. A circle starts at the top and it moves its way across. And if you'll recall the last video that I did, it gets to the edge and the circle disappears and reappears over here. What I would like to try and do in this video is I want it so that this circle gets all the way to the edge, and I'm hoping my cursor highlights are turned on so you can see this. And instead of vanishing and reappearing or just vanishing altogether, it bounces and goes back in the other direction. That's my goal. So in order to do this, I'm going to write out some pseudocode, and then I'm going to ask you guys to pause and think about this on your own. So what I want to have happen is if circle reaches edge, I want it to reverse direction and go back towards other edge. If it's not on edge, I want it to keep moving forward, and forward here is left to right. Okay, so I would love for you guys to just think about this. Think about what you know about these values. And also think about what you know about how we are creating movement, and just pause this video and see if you can write this into your code and then come back here. Okay, I'm going to assume that you've paused and come back. I'm going to code out what I often see students try and do first for this, and then we'll take a look at it together. So what I often see is students saying, circle reaches the edge. That would be if circx is bigger than 400. Sometimes I see greater than or equal to 400, so we can keep that there, it's fine. I want to reverse the direction, and I see lots of people think reverse the direction must mean go backwards. And go backwards, if I'm adding here, must mean subtracting. So I see people write circx equals circx minus circspeed. And sometimes people even throw in like an else, that if it's not bigger, then this is where it should be moving forward. Actually, you know, we're going to come back to this later, but I see some people adding this in. We essentially already have this line happening up here, so I'm going to ignore this for right now. But just know that we could talk about it later. So I see this, and I see people hit play, and I see people sit back and watch, and my numbers are getting bigger and bigger and bigger. You can make your speed faster if you want. And then it gets here and it gets stuck, and people wonder why it's getting stuck. So let's just walk through this. we said that if circle x is greater than or equal to 400, we should subtract the speed from circle x. But we are also saying, over and over and over in our draw function, that we're adding speed. So essentially what's happening is you're getting to like 399, it's adding, it's subtracting, and you're getting stuck at 400. The computer is like trying to move up to 401, but you have this thing telling it no, subtract, go back to 400, and you just wind up stuck. So then I see students messing around with, maybe it shouldn't be equal then. Maybe it just needs to be bigger than 400. And I see it get here and get here and get here and get here and get here. And now we're actually stuck at 401. Now it is bigger than 400, but the computer is still trying to subtract and add at the same time, and it's still stuck. So that is usually when I see this conditional else statement come in, where people write something like this, or they write an else if. And what we see then is our circle moving really fast, because it's essentially adding twice, but it still gets stuck. The only difference now is it's able to get stuck at 402 because we're doing this addition 2 times. So none of this seems to be our answer, and this can be very frustrating, but there's another way that we can approach this problem that has to do with this speed variable that I've been telling you to put in every single code along video you've seen. In order to make this happen, rather than changing what we're doing to circle x, I think that we could change the speed to its opposite. And I'm in fact going to edit my notes here to say if circle reaches edge, change speed to opposite. So right now, my speed is a +1. The opposite of +1 is -1. And saying circle x plus -1 is the exact same thing as saying circle x -1. And I will make a note right here. Circ x plus 1, plus -1 is the same as circ x minus 1. Those are the same ideas. So here, I'm going to say that if circle x is greater than 400, then I want circ speed to be equal to circ speed times -1. That is the easiest way to turn something into a negative, is to multiply it by -1. Even if my speed was, let's make it 3 so that it moves a little faster, 3 times -1 is still going to give me -3. So let's see what happens now. It moves and it moves and it moves and it gets to the edge, and it bounces and it goes back. Now our problem is it bounces and goes back and it goes off the screen on the left side. So to fix this, I could make another conditional, but I could also just say, if circle x is greater than 400, or, and in JavaScript, or are the parallel lines that are, you would hold down shift and hit the /line key that's between your delete, backspace, or enter return button on your keyboard. It's 2 of those guys. I could say if circle x is greater than 400, or circle x is less than 0, because less than 0 means it's past this line on the left side, take whatever that speed is and multiply it by -1. If circ speed was a positive, when I multiply it by a negative, it becomes negative. If circ speed was a negative times a negative gives me a positive number. So now when I hit play, my circle gets to the edge, it bounces, it gets to the other edge, it bounces, and just so that we can see this, let me make circ speed show up. 175, 250. Okay, so my circ speed is 3, it's now -3, it's now 3, it's now -3. So the movement has stayed the same, nothing changed up top. The only thing that varied was this value here. And this will work with any number. I could, up at the top, create a circle speed that is a random number between, let's say, -3 and 3. I'm making it an integer just so it displays nicely on the screen. You don't have to. So this will give me a random speed every time. Right now it's 2. Now it's -2. If I play this again, I might get a speed of -1 and 1. It is always, always, always going to be moving, just at different rates and different places and different speeds. So you guys are going to take this, you're going to do a little play with it, and then you guys are actually going to try and make a project where things will bounce all over the screen. And my biggest hint to you, do not make your speed for your X and Y the same. Good luck.